Hello everyone. Today I'll be showing you guys the derivatives formula which you will need for this SLC board examination. And you'll also need to do the exercise and for the application of derivatives as well. So let's start with the trigonometric hyperbolic derivatives. Now let's recall what the derivatives of trigonometric functions are. So sin x we know is cos x, and for cos x it's sin x. Well, minus sin x. And for these we have a nice trick called the SST, which stands for sec tan. So the derivative of tan, you cover up this, you will get sec square x, and for sec x, cover up this, you get sec x tan x. Now for cot x, it's similar to tan x, in which it is minus cosec square x, and for cosec x, it is minus cosec x cot x. Now for the hyperbolic functions, it is almost the same. Well, sin hx, cos hx. Cos hx minus sin hx, right? No, it's just sin hx. And tan hx is also sec h square x, cot hx minus cosec h square x, sec hx minus sec hx, tan hx, and this is minus cosec hx cot hx. Now here you can see that the sign is just reversed for the cos and sec. And here will cos and sec, well, sec is equals to 1 by cos. So cos and sec lies in the cos family. And a good way to remember the derivative of hyperbolic function is to see that hyperbolic has a c at the end, which stands for cos family. So you just change the sign from the trigonometric here for the cos family. So here cos x is equal to minus sin x. So for cos hx it's just sin hx. And the rest are the same, and also sec hx equals to minus sec hx tan hx. Now this is for the normal trigonometric hyperbolic functions. Now let's do it for the inverse functions. So for sine inverse x, this is 1 by root 1 minus x squared. And for cos x, it is minus 1 by root 1 minus x squared. For tan x, it is 1 by 1 plus x squared. For cot x, it is minus 1 by 1 plus x squared. For sec x, it's 1 by x root x squared minus 1. And for cosec x, it is minus 1 by x root x squared minus 1. Now here the hyperbolic functions, the inverse hyperbolic functions, you kind of have to remember the formula. But I have devised a sort of a pattern that could be helpful for you guys to remember, or you can also create your own kind of pattern that you feel easy to remember as well. So for sin h inverse x, here for the sine family, this includes sine and cosec hx. What I do is called reversing the sign. So here for the sine inverse x, it's 1 by root 1 minus x squared, and here for sin hx, it is 1 plus x squared. So here the minus changes into a plus, and for cosec hx, it is 1 by x minus root x squared plus 1. So here the sign, this sign changes, the outer sign doesn't change. So only the function part or the variable part inside the root changes. Now for cos hx, I like to call taking the negative common. So here if you take the negative common, we will get 1 by root x squared minus 1. Why I do speech marks is because, well, if you take negative from here, what you'll get is minus 1 by minus x squared minus 1. And here what you do is you supposedly cancel the minus on numerator and denominator, even in actuality if you can't, but this is just a good way to remember and cancel the negatives. Take the negatives common and cancel. So this applies for the cos family, so this includes sec hx as well. So this becomes minus 1 by x root 1 minus x squared. So you take the 1, so you take the minus common, and minus goes up, becomes this. And for the tan hx, it is quite simple. What you do is you change the plus to a minus. So 1 by 1 minus x squared. And for here, cot x, well, what you do is well, this one kind of doesn't have a pattern, but here, if you notice on the derivative of tan h, this all should be inverse. Tan h inverse x, you can see it's 1 by 1 minus x squared. And for cot h inverse x, it is minus 1 by x squared minus 1. So what you can do is take this common, and the minus minus cancels, give us the derivative of tan h inverse x. So you might say, well, won't the derivative of the tan h inverse x and cot h inverse x be the same? No, because there is a condition. To remain this as positive, the modulus of x should remain less than 1. And for here, for this whole thing to remain negative, that means that modulus of x, the actual value of x, should be greater than 1. Now it is quite easy to remember for these two, because from tan x you can just change the plus to a minus, and then just actually take the negative common for cot h inverse x. Well, I hope you found these derivatives patterns quite useful, and we'll be looking at the derivatives exercise on the next video. Thank you.